Welcome to this Vizel tutorial. In this video we're going to cover how to create Outlook emails using Excel VBA. So the video is all about how you can control Microsoft Outlook by writing VBA code in an Excel project. There's quite a lot of topics to cover and it gets quite complex, but we'll start with the basics of how you can reference an Outlook object library and how you can simply open up Outlook and create a new email object. We'll show you how to set basic email properties, such as who the email is going to go to and what the subject is, and also how you can set the format of the email and add text to the body of the email depending on which format you've chosen. We'll show you how you can include a simple signature and add basic attachments to the email before we show you how you can then make the code version independent to make sure it will work on almost any version of Office. For the latter half of the video we're going to get into more complicated techniques, first of all showing you how you can write complex body text which is built up of various values of cells, and we'll include there how you can build an HTML email by using various HTML tags and applying basic formatting as well. Towards the end of the video we'll look at how you can then use the Microsoft Word editor to generate a rich text format email, and then finally we'll show you how you can make sure you can choose a specific signature file to be included at the end of each email. So there's certainly a lot to do, and it gets quite complicated certainly towards the end. Let's get started. For the first example in this video, we're going to write some VBA code in Excel that creates a brand new Outlook email and then sends that to somebody. We'll stick with basic plain text emails to begin with, and deal with the more complex HTML and rich text formatting later on. And for this video I'm going to be using Office 2013. Although if you're in Office 2010 and 2007, it doesn't really matter, the same code will still work. So to get started I need to head to the VB editor, and I've actually already set up a brand new module for myself called Using Outlook, and I'm going to begin a new subroutine in here called Send Basic Email. Before I start writing any code, I want to make sure that Excel will understand what I mean when I start talking about things like the Outlook application and email objects. At the moment Excel doesn't even know that Outlook exists, so we're going to widen Excel's vocabulary by setting a reference to Outlook's object library. If you've watched the videos on how to create Word documents or PowerPoint presentations, this is exactly the same process. Head to the Tools menu, choose References, and then scroll through the huge long list to find the option for Microsoft Outlook. There will be a version number listed after the word Outlook in the list. So in my case it's version number 15, because that's because I'm working in Office 2013 and that's the internal version number 4 of that version of Office. If you're working in Office 2010 you'll find this is the version number 14, in 2007 it's version number 12, there is no version number 13, which is good news if you're superstitious I suppose. So just check the reference for the version you have available, and then click OK. And now Excel knows how to talk to Outlook, and it will understand the definitions of all the main keywords that are part of the Outlook object library. Now we can declare a variable which will hold a reference to the Outlook application. So I'm going to call mine OLApp, short for Outlook application, as, and in the IntelliSense list I want to look for the word application. And I'll find that that appears twice in the list, once for Excel and once for Outlook. It doesn't actually matter which of the two you choose at this point. This reference actually gets resolved when the code gets compiled. And what Excel will do is it will check through its list of references that we have set, and the first library it encounters which has a definition for what an application is, that's the type of application you'll get. So because Excel sits above Outlook in this list, this variable will actually allow us to hold a reference to the Excel application. We can change the priority of our libraries by selecting them and using the arrows to increase and decrease their priority, but you can never move Outlook above Excel. As you're programming in Excel, that kind of has to take precedence. So the way to get around this is, rather than referencing the word application directly, you can qualify it with the name of the library to which it belongs. So if I press Ctrl and Space to display the IntelliSense list, I can look for the word Outlook in the list. That's the reference to the Outlook object library. You see this little icon, which is a set of books. And then in there I can type in a full stop and look for the word application here. And there's only one definition for an application in the Outlook library, so that's the type of application we will get. So that's the variable declared which will hold the reference to the application. What we need to do next is actually start Outlook running. To start Outlook running, we can create a new instance of the Outlook application. And to do that we can say set OLApp equals new Outlook.application. So that line starts Outlook running, although you wouldn't physically see Outlook appear on screen. One way to prove that Outlook actually is running is to use the Windows Task Manager application. If I press Ctrl and Shift and Escape on the keyboard, that will display the Windows Task Manager. And on the Processes tab, I've got my processes sorted alphabetically by name. I can click on the column heading there to do that. If I scroll down to where Outlook will appear when it is actually running, what I can then do is head back to the subroutine. I'm going to use F8 to begin stepping through. So if I execute this line of code, and then switch back to the Task Manager, I'll see I now have a process called Outlook.exe. So that's a process that's been generated by that line of code. Now this process will remain available until we finish with it. So when we end the subroutine, if I press F8 here to end the subroutine and then quickly switch back to the Task Manager, you'll see after a short period of time the Outlook process will disappear. So when you finish working with Outlook, it will automatically tidy up after itself. So I'm going to close down the Task Manager application. Now that we have a new instance of Outlook available, what we can do is actually make use of it to create a new email. Just before we create that new email, I wanted to mention a couple of other techniques you could use to create the new instance of Outlook. If you've watched the videos on Word or PowerPoint before this one, you'll be familiar with these two techniques by now, so sorry if this is a bit boring by this point. But the first technique I'm going to mention is something called an auto-instancing variable. I'm going to make a copy of this subroutine and paste it in down below. Make a small change to the name of the routine. I'm going to call it auto-instancing. And the idea behind an auto-instancing variable is that you don't choose when to create the new instance, so I'm going to remove that line altogether. Instead, you can incorporate the new keyword into the variable declaration. Slightly misleadingly, that line doesn't actually create the new instance of Outlook. What happens is, any time the OLApp variable name is used in code, the VB editor checks to see if it references an application yet. And if it doesn't, it will create the new instance automatically. So if we were going to do something to the application, that's the point at which it would be created. Now that sounds really convenient. Basically, you can save writing an entire line of code there, can't you? But there are two small downsides to it. First of all, it's not just the first time you use this variable name in code, it's every time you use OLApp in this subroutine, the VB editor has to check if it references something or not. So that does add a small overhead to the subroutines that you write. The other small problem is that you can't yourself test if OLApp is nothing, then do something. So for example, you might want to display a message. There's a very simple example. Outlook isn't running. Because as soon as the VB editor encounters that keyword, then that's the point at which it actually starts running. So if I display the Task Manager application at this point, just so you can see Outlook isn't running at this stage, if I begin stepping through this routine, do you see it skips over the statement? So this logical test failed, and that means that Outlook must now be running, and indeed it is. So that's the idea of an auto-instancing variable. It's one that gets created automatically as and when it's needed. But there are a couple of small downsides which mean that I don't tend to use them myself in the real world. So for the rest of this video, we're going to be going back to the non-auto-instancing variables. The other technique that you could use to create a new instance of Outlook is related to version control. And essentially what happens if you sent this workbook to somebody with a different version of Office installed to you. So if I head to the Tools menu and choose References, earlier I set a reference to Outlook 15, which is part of Office 2013. If I sent this to somebody who only had Office 2010 or 2007 installed, the Outlook library here would be listed with the word missing next to its name, and the code wouldn't actually work. The libraries for Excel and Office would actually automatically change their versions down to whichever the user was running. It's just extra references that you've set that wouldn't automatically do that. So what I'm going to do here is uncheck the reference to Outlook and click OK. And that means at this point I can't run this subroutine at all, because if I try to do that, I'm told that basically Excel doesn't understand what an Outlook application is. So if I hit OK and reset the subroutine, I'm going to make a quick copy of this and paste it in down below. I'm going to call it send basic email CreateObject. And the idea is that rather than referencing the Outlook application class, which Excel doesn't understand at this point, you use the more generic keyword object. And then instead of using the new keyword, you call a function that's part of VBA called CreateObject. If I open a set of round brackets there, you'll see that it's got two parameters, and there's one compulsory one called class as string. So a class is like an Outlook.application. It's a type of object, or a definition for a type of object. The CreateObject function allows us to pass that in as a string of text, which means that the VB editor doesn't have to understand what that is. It doesn't have to interpret what Outlook.application is when the code is compiled. So that means, again, if I use the F8 key, in fact, if I display the task manager first, Control-Shift-Escape, and scroll down to where Outlook will be, and then if I step through the routine using the F8 key, we'll see, if I go back to the task manager, that I have a new instance of Outlook. So essentially, the CreateObject method allows you to make your code version independent. These techniques are distinguished by the terms early binding and late binding. So late binding is when you don't set a reference to an object library, you rely on the VB editor to work out which library it should set automatically when the code runs. The one small downside to late binding is because we don't have a reference to the object library, we don't get any help in the form of the IntelliSense list when we write our code. So if you remember earlier on when I said OLApp dot, you got the full list of all its methods and properties. Now you have to know exactly what code to write because you don't get any help whatsoever. In the real world, what you tend to do is start writing your code using the early binding technique, and then when you're ready to release the program to other people, that's the point at which you switch to a late binding technique. And that's the approach we're going to take in this video. So I'm going to remove the late binding method from there, and I'm just going to remove that comment as well. And I'm going to head back to the Tools menu and choose References, and then scroll down the list to find Microsoft Outlook 15, check that box again, and now we're ready to start writing some code that will actually create the new email. When I create the new email object, I want to store a reference to it in a variable to make it easier to work with. So to start with, I'm going to declare a new variable called OL email as outlook.mailitem. To create the new email itself, I'm going to say set OL email equals. Then I'm not going to use the new keyword. What I'm going to do is use a method of the Outlook application itself. So I'm going to say OLApp.createItem, then open a set of round brackets to see a list of all the types of things that I can get Outlook to create for me. Now obviously we're creating a mail item object, so I want to create or specify that I want an OL mail item object created. But you can also create things like contacts and appointments and all sorts of other cool things as well. We're going to stick with emails for now at least, so I'm going to close the round brackets after that, and that will give me access to my new email object. Now, just as when we created the new instance of the application, we didn't actually physically see it appear on screen, you wouldn't see the email that you've created appear either. But it's fairly straightforward to make that email visible. So what we're going to do is say olemail.display, so display is a method of the email object, and then all we need to do is run the subroutine to see what we end up with. So we ought to end up with basically a blank email. For the time being at least, you will have any standard footer text that you've set up for your email account. Other than that, we have to fill in every single property of the email before we can actually then send it. So that's the next step, filling in the various properties of an email object. Because we're going to be changing lots of properties of the same object, rather than having to write OL email several times, what we can do is use a with statement. So I'm going to put the word with in front of OL email, and then I can take the dot display down to the next line, make sure that I have an end with statement as well to go along with that. And then we can simply carry on filling in the various properties of the email. So let's start with who the email is going to. There's a property there called to, and I can make that equal to an email address. I better not give you my email address, should I? Let's put in a generic email. I can put someone@somewhere.com. That will do as a very, very generic example. Then we could put in a CC or a BCC property as well into the carbon copy or blind carbon copy fields. The email address themselves, you don't just have to put in a single email at a time. You can put in a list of addresses. You can have a semicolon delimited list of email addresses. So I could say someone else@somewhere.com, or I could put in a named mailing list. If you have a mailing list in your Outlook account, you can put in the name of the mailing list there. Essentially anything you would ordinarily do if you were filling in this to field in the email. I'm going to stick with a single email address just for now. The next thing I'll do is fill in the subject. So I'm going to say .subject equals, I'm going to call that something like movie report, and then In fact, for now, I think that's probably enough. What I want to do is just have a quick look at what the email will look like when I run it. So if I press F5, this time I should see when the email appears, we get the email address filled in, the to field, and we get the subject filled in as well. So that's how easy it is to change basic properties of an email object. I'm just going to close that down without saving the changes. The next thing I want to do is start adding to the body text of the email, and that's where things get a little bit more tricky. The main thing which makes setting the body text of an email so awkward is that Outlook has 3 different formats you can use to compose an email in. So if I quickly switch into Outlook, and I've displayed the Outlook options dialog box here already, so if you're in Office 2010 or 13 you can enter the File menu and choose Options. In Outlook 2007 I believe it's the Office button and Outlook Options. On the Mail tab you can see the default format that messages are composed in. So mine's set to HTML, but there are 2 other types, rich text and plain text. The format that's used for an email determines which property you should use to set the body text. So if I cancel out of that dialog box and close down Outlook, you'll see that if I run this subroutine now, my email says HTML at the top of it, so it's in the HTML format. But I can change that either manually from the Format Text tab. I can choose plain text or rich text, but I can also change that property in code. It's always worthwhile doing this to make sure that the email that you generate is the format that you're expecting. So let's change that property first of all. The property which changes the body format of your email is fairly conveniently called body format. So if I say .body format equals, I get a list of choices: HTML, plain and rich text, also unspecified, which I'm not going to consider here. So I know that my email is already set to an HTML format, so let's change it to a plain text email instead. So if I do that and then run the subroutine, you see 2 things. First of all, you'll have the word plain text here rather than HTML, and also, somewhat disappointingly, we've lost our signature. This is actually just a feature of where you change the body format of the email. What I'm going to do is close that down without saving the changes, and instead of setting the body format after the email's been displayed, I'm going to move that line, so I'm going to cut it from there and place it at the top. So I'm going to place it before we display the email. So having done that, if I run the subroutine again, we will see that we've got a plain text message again, but we actually retain the signature, so that's quite important. If I just quickly change it one more time to the other options, so rather than plain, we'll have rich text. So instead of rich text, and run the subroutine again, and this time we'll see it's a rich text email, and we've got the nicely formatted version of the signature. So that's the first step, changing the body format property. The next step is to actually change the body text of the email. We've got several choices of how we do that depending on which body format we've chosen. So the generic way that you do this, regardless of which body format you've set, is to modify the body property. So if I say .body equals, let's put in a simple line of text, let's say dear someone. So again, regardless of which body format you've chosen, this will allow you to set the body text, and if I run that one, we will see we've got a rich text email there with the phrase dear someone in it. Again, of course, we've lost the signature, but we'll resolve to get that one back in a few moments. Let's just check quickly that it will work, whether it's an HTML email as well. So a format HTML, and if I run it again, we'll get an HTML email with dear someone, and again, we've lost the signature. And one more time, we'll run it as a plain text email, format plain, one more time, and there's the plain text version. Okay, so the body property is the most generic way to do this. It's worthwhile quickly mentioning that there are a couple of other properties you can use, dedicated properties that you can use for HTML emails. So if I revert the body format back to an HTML email, and then instead of just saying .body, I'm going to say .html body. It won't make any difference if I just use a basic simple string of text like this. If I run that one, we will get a fairly straightforward string of text. But the beauty of the HTML body property is that you can put in proper HTML tags. So if I did something very quick and simple just to demonstrate the principle, if I put in h1 tag and then close that tag at the end, so I'll say /h1, that will put in the phrase dear someone formatted as heading 1. So if I run that one this time, then we'll get a completely different format. So we'll come back to the HTML body a little bit later on and show you a couple of other things that you can do. There is one other property as well that you can modify that I'm not going to demonstrate in too much detail here, but if I had a rich text format, there is a RTF body property. Now this one's a little bit more tricky to work with. The RTF body doesn't allow you to put in simple strings of text like this. The RTF body property only accepts a certain kind of data. So if I try to run this one at this point, this will fail. So I'm going to come back to the RTF body again a little bit later on and show you what you can do with that. So for now, we're just going to stick with the basic body property. So I'm going to change that back to the body property and change the format of the email back to plain text. The next thing to do is to make sure that we actually retain our email signature. So let's solve that problem. Now, assuming that we were going to change the body text just using a single instruction, the easiest way by far to incorporate the existing signature is just to concatenate the body property to the end of our unique phrase of text there. So what I can do is I can use an ampersand to concatenate. I want a new line character, so I'm going to use a VBCRLF, Visual Basic Carriage Return Line Feed, and the existing body property of the email object. If I just say .body, that will tag in whatever is already in the body to the end of my custom phrase. Now there's a small problem with the way this works. If I run the subroutine at this point, we'll see that it has apparently absolutely no effect whatsoever. And the reason for that is because at the point at which we're calling on the body property, the signature hasn't been generated yet. That only happens when the email object gets displayed. So if I want to make this work, again, the order of instructions for Outlook is much more important than you'd expect it to be. So I'm going to change where the display method occurs. I must make sure that this happens after the body format property, because as we saw, if I display it and then change the body format, we lose the signature. So this changes the body format and then displays the email which generates the signature, and then we can reliably pick up on whatever was already in the email using the body property. So finally, having done all of that, if I run the subroutine one more time, there we go, there's our basic custom phrase with our signature at the end of it. Now doing the same thing for an HTML email is very similar in principle. If I close down this copy of the email and don't bother saving the changes, there are a couple of things I'll change. First of all, I'll change the format of the email to an HTML email. Then, rather than changing the body property, I'll change the HTML body property. The character code for joining a line break in HTML is not VBCRLF, that's a Visual Basic constant. So the character code for HTML is the break tag. So in a set of double quotes, the letters BR inside a set of angle brackets. And I could have actually just put that in after the dear someone. That would have happily gone in here. In fact, let me put another one in here as well, so I'll get 2 line breaks. What I also want to do is modify the body property that I'm calling on. Because if I run this one at this point, all I will get is the basic formatting of the body property. What I really want is the nicely formatted HTML body. So if I get rid of that and don't bother saving the changes and read the HTML property, when I run the subroutine again, I'll get the nicely formatted version with my original signature format. One more simple thing that we could do with this email before we get into the complicated stuff is adding an attachment to it. So what I'm going to do is attach a Word document to the email, and the one I'm going to add is this one, Movie Report, which is sitting on my desktop currently. So I'm going to use this folder path to attach the document. I'm going to copy that to the clipboard at this point, because I'm going to need that in a moment. Back in the VB editor, to add an attachment to an email is really straightforward. You reference the attachments collection of the email object, and then simply say, add. And there's a single compulsory parameter of that, the source parameter, which, as you've probably guessed, has to be a file and folder path. So if I paste in the path that I've just copied and add a backslash, and then say movie report.docx, that will add that particular document. Now, in the real world, of course, this relies on the user who's running this code to always be me, or logged in as me at least. So what I might do here is replace the C users Andrew Gould with a call to the environ function, which lets me ask for the user profile, and that will return that path. And then if I concatenate onto the end of that the desktop folder and the name of the file, that will make sure that it works for whoever's running the code, as long as, of course, that file exists in that folder. So if I run that subroutine at that point, that should show us that the document gets attached. One last little tweak that we'll make is to add the send method to the end of the with statement, and as you've probably guessed, this will literally send your email. This is something you only want to do if you're absolutely 100% confident that the email you've generated is correct and will go to the correct person. I've heard some wonderful horror stories from people in the past about sending auto-generated emails, either to the wrong person or with the wrong content in it, and you definitely do not want to fall into that trap. So the send method will send the email. I'm not actually going to run this one at this point. Just to mention that this is how you would do it, I'm going to comment this out for the time being so that I don't accidentally do that. So there's the basics of generating emails with Outlook. Earlier in the video, I mentioned the idea of using a technique called late binding to make your code essentially version independent. And just while we still have a fairly nice simple version of our subroutine, before we make it more complex, I'd like to revisit that idea and show you how you could convert this subroutine into using a late binding technique. So what I'm going to do is make a copy of this subroutine and paste it in down below, and then change the name of it so that it's called send basic email late binding. Using a late binding technique means that we can remove any reference to a specific version of Outlook's object library. So if I head back to Tools, References and uncheck that box and then click OK, that means of course that the code won't work anymore. If I try to run it, I'll get compile errors, and essentially anything that I've used from the Outlook object library, any keyword or class, the VBA editor now has no definition for what that type of object is. So if I click OK, the first thing we'll have to do, if I just reset the subroutine, is change any explicit reference to an Outlook class to the more generic object. So that goes for both the Outlook application and the Outlook mail item. We'll also have to change the way that we create the new instance of Outlook. So rather than using the new keyword, we can change that to a call to the CreateObject function. And the reason we're using this is because it allows us to pass in the class of object we're creating as a string of text, which means that that doesn't have to be interpreted when the code gets compiled. It's interpreted at runtime instead. So there's one more set of things we'd also have to change. They're a little bit more difficult to spot, but if I try to run the subroutine again at this point, there's going to be another couple of compile errors cropping up. And these are to do with the constants that we've used from Outlook's object library. Now a constant is actually just a convenient keyword that we can use, which actually represents a number behind the scenes. And if you want to find out what those numbers are, really the only way to find out is to use Outlook's object library. So at the moment I'm going to have to recheck the reference to Microsoft Outlook. So let's scroll through the list and find that again. And there it is. And if I begin stepping through this subroutine now at this point using the F8 key, the most convenient way to find out what value a constant represents is to simply hover the mouse cursor over its name. And the tooltip will tell you what value that constant actually refers to. So an OL mail item actually has a value of 0. So if I replace OL mail item with the value 0, that will now do exactly the same thing. Likewise, the next one is OL format HTML, and that has a value of 2, so I can exchange that for number 2. And that's all of the constants that I've used in this fairly small, short subroutine. Obviously, your job is going to be a little bit more difficult when you have a much larger subroutine, but that's the process that you would go through. So if I reset the subroutine again now, and head back to the Tools menu and choose References, and uncheck the reference to Outlook, I can run this one more time, and find that we get exactly the same results as though we'd used an early binding technique, but with the added convenience of allowing this code to work on almost any computer. Of course, as we saw earlier, the big disadvantage with using late binding is you don't get any help whatsoever in the form of the IntelliSense list. So in my with statement now, talking about an OL mail item object, if I type in a full stop, no IntelliSense, which means I have to know every single method and property to use it effectively. So for that reason, we're going to revert back to an early binding technique for the rest of the video, but hopefully you're aware now of how you can go about changing your code later on to a late binding technique to make it version independent. So just for the rest of the video, I'm going to remove that subroutine altogether and go back and check the reference to Microsoft Outlook, and then we can start thinking about doing somewhat more complex things. So find Outlook, check the reference, and there we go. For the next part of the video, I'd like to look at how we can generate more complex body text for the emails that we're creating. So to get started, I'm going to make a copy of this entire subroutine, and I'm going to put it into a new module. I'm going to change its name to Send Complex Email, and I'm going to change the name of the module to Using Outlook Part 2. So the example that we're going to do here is we're going to write an email that has a copy of this table of data in it. Now, unfortunately, we can't simply copy and paste at this point using the basic properties of our email. So what we're going to have to do is write out the contents of each individual cell into the email itself. We're going to do this first of all using a plain text email, because that's slightly simpler, and then we're going to have a look at how to do it using HTML. But essentially the process will be the same. We're going to be looping over this range of cells here from A2 down to A15, and for each row we're going to loop over the cells in that row and write out the contents of each cell one by one into the email. We'll also have to work out where we put in our line break characters to make sure the rows of data go into separate rows, and we're going to do all of this by creating a custom function. But as I said, we're going to do this first of all using a plain text email. So back in the VB editor, what I'm going to do first is modify the body format to OL format plain. And then, of course, not changing the HTML body, we're going to change the basic body property. And of course, we don't want to insert an HTML tag into that, so we're going to convert that into, we could use VBCRLF, or we could use VB new line. I'm going to go with the new line this time. Just to tidy up a little bit as well, I'm going to ignore the idea of the attachment. So the attachment basically contains the data that I'm going to show in the email now. So I'm going to remove that line altogether. And I'm also going to just remove this little part here about sending the email as well, just to make things a little bit tidier. So we're focusing essentially on what happens here when we set the body text. Now, because the code to generate the body text is going to be quite long, as I said, we're going to separate it out into a different function. So just below the subroutine, I'm going to declare a new function called getMovieData, and the function is going to return a string. We'll need several variables in this function in order to process our table of data, so I'm going to have dim film column as range, and that's going to hold the range of cells in column A that comprises our list of film IDs. We're also going to have a variable called film row as range, and that's going to hold each individual row of data as we process the column. We'll also need a couple of generic range variables as well. I'm going to have one called R as range and one called C as range, and that will let us process the loops when we're looping over the collections of objects. That's all the range variables. We will also need to have a variable where we can build up the string of text which represents the body of our email. So I'm going to call this one something nice and short and simple, like str, as a string. Now what we can do, if I just scroll this down a little bit to make it a bit easier for you guys to read, what I can do now is make sure that we go to the correct worksheet. I'm going to say sheet1.activate, and then I'm going to set which range of cells is stored in the film column variable. I'm going to say set film column equals range A2, so that's going to be the top cell in the list, and the bottom cell in the list is from range A1 dot end XL down. So if you've watched previous videos in this series before, you'll be familiar with this technique by now. Essentially what it does is sets the top cell in the list to be cell A2 explicitly, and the bottom cell in the list is going from cell A1 down to the end of the list in a downwards direction. So you can simulate that by holding down the control key and pressing the down arrow key on your keyboard, and that jumps down to the bottom cell in the list. So this will guarantee that the code will work regardless of how long the list is, assuming that there are no gaps in the list, as we've mentioned several times before. So that's the column of cells stored. What I can do now is write the code that will loop over that column of cells. To do that, we're going to use a basic for each loop. So I'm going to say for each R in film column, a couple of blank lines, and then say next R. So that loop there will process the column of cells from A2 down to A15. It will look at each one in turn. What I would like to do for each row is to store a reference to that row of cells in the film row variable. So again, that means a very similar technique, going from the left-hand edge this time to the right-hand edge of the sheet. So this will make sure that it works however many columns are in the table of data. So the first job inside our first loop is to set a reference to a range of cells in the film row variable. So set film row equals range. Now the starting cell this time will be whichever cell is referenced by the R variable, so that's simply R, and then the end cell will be R.end XL to right. And again, this is assuming that there are no gaps in our list at any point, but that will store the row of cells in that variable. Then we can write the inner loop, which will say for each C in film row, a couple of blank lines, and then say next C. So that's the basic loop structure set up. All we've got to do now is start writing out the content of the cells into our string variable. Essentially what I want to do here is for each cell that I encounter, I want to make the string variable equal to itself and the contents, or the value, of that cell. I'd also like to make sure that the content of each cell gets separated from the next by using a VB tab character, so I can say and VB tab. Now the small problem with doing it this way, of course, is that every single cell in the row will have a tab character after its value, and that includes the last cell in the row as well, so the final column. I don't want to add a tab character to the last cell in the column, so rather than just always adding a VB tab to the end, I'm going to use an if statement that will check if c.column is less than r.end xl2right.column, then str equals str and a VB tab, end if. So this guarantees that I will only get a tab character as long as the column that I'm in is before the last cell in that row, the last column in that row. We can use a very similar technique to add on the new line character at the end of each row of data. So just after we finish looping over all the cells in a particular row, we can work out whether we need to add in a new line character. So we only want to do that as long as we're not on the last row of the table. So I can use an if statement. I can say if r.row is less than range a1.end xl down dot row. Then str equals str and VB new line, end if, and that will give us the complete table of data from the contents of the cells in Excel. What we finally need to do to make this function work is tell the function to return a value by saying, after the loop, get movie data equals str. So whatever string we've built up in that variable, that will be the string of text returned to the function results. So there's the whole thing in one page. Now we can simply plug in the results of this function into the main subroutine sitting at the top of the module. So to do that, I'm going to head back up to the top, and after we've written out the greeting and a new line character, I think I'm going to have another new line as well, so that I get a blank line between the greeting and the table. And then I can simply concatenate in the result of my getMovieData function. To do that, I just reference getMovieData. So, having done all of that now, what we should be able to do is run this subroutine and get a not particularly pretty table, admittedly, but the important thing is we've got the complete table of data from Excel into the email. That's the important part. The formatting is a little bit strange because I've used the VB tab character, and the width of the tab character varies depending on how many characters are in each division of the page. So when there's a nice consistent set of or number of characters in the values, then you get nice consistent spacing. When the number of characters differs, you get somewhat more inconsistent spacing. But as I say, don't focus too much on the formatting here. This is again a plain text email. You're never going to get great formatting in a plain text email. The important thing is we've got the complex table of data written into that email. Now, if you did want a slightly more presentable version of this table of data, then we're going to have to use either an HTML or a rich text format document instead. And we're still not at the point where I want to deal with rich text format documents just yet, so we're going to show you how you can generate this table in an HTML email, and actually format the table as well. So I'm going to close down this email here, and don't save the changes. Then I'm going to make a copy of everything in this module, or at least the subroutine and the function. So I'm going to copy those two things out, and I'm going to create another new module. You can probably guess what this one's going to be called. I'm going to paste in these two procedures first. Then I can rename the module as Using Outlook Part 3. And then I can rename my two procedures. First of all, the function I'm going to call getMovieData HTML. And the subroutine, sitting at the top, I'm going to call SendComplexEmail HTML. That, of course, means that I'm going to need to modify a couple of things in this subroutine as well. So I'm going to have to modify the body format to OL format HTML. And of course, I want to change the body text to use HTML body instead. So let me just scroll this across so we can see the whole thing in one screen width. Again, I can't use the VB new line characters to put in the line breaks, so I'm going to change these to, in fact I can do this in one single go, can't I? In fact, I don't even need to concatenate those. I can just add in the line break tags into the original string. So I can say break, break. Get movie data then as well. I don't want to call the original function, I want to call the new version of the function that I'm about to create, gets movie data HTML. Now we have to work out how to generate an HTML table, which is a little bit different to creating just a simple plain text table. Just before we start modifying this function, I think it's worthwhile having a quick look at what HTML tables actually look like. Now, I'm no HTML expert by any means, but I know enough to get by. So I've opened up a copy of Notepad here, and just to show you what a basic HTML table would look like. There are three main tags involved in an HTML table. The first one is conveniently called table. So HTML tags get written out in a set of angled brackets, and once you've opened a tag, you also have to make sure that the tag gets closed later on. So a couple of lines further down, I'd have a closed tag, which is essentially the same, just with a / in front of the name of the tag. So that creates a table. Inside the table then we have to define the rows and the columns, or the rows and the cells technically. So inside the table, I'm going to tab in here that the indenting is not important, it's irrelevant. Just like in VBA, the indenting does not actually matter, it just helps us to read it. So a row is defined with a tr tag, and again you need to close that tag later on as well. And then for the individual cells in that row, use the td tag. So I've got a td, and then inside the td tag, what I can do is write out the contents of the cell. So in between those two tags, I could say something simple like column 1. Then if I wanted another column or another cell in that row, I could simply open up another td tag. I don't know why I didn't just copy and paste that actually, and call that column 2. Close the td tag, and that will generate a table with a single row and 2 columns in it. If you wanted more rows then, with the same number of columns, it's very, very simple. You just have more tr tags, so I can copy and paste those quite happily, and then just change the values here. So I can say this is row 2, I suppose, and this will also be row 2. And that's the basics of how an HTML table works. It's just a sequence of nested tags. One table tag, table row tags for the number of rows, and td tags for the number of cells or columns in each row. So what I'm going to do is I'm going to quickly save this file as a text file on my desktop. Oops, I better give it a name first, hadn't I? That's why I wouldn't save. HTML table, save it, and then close it down. And then what I'm going to do, just to show you how it actually works, I'm just going to change the txt extension to an htm extension, which is fine. And then I'm going to open it up using a web browser, so in this case Internet Explorer. So what this does, it will translate that HTML text into an actual document. So that's an HTML document. So that's what our basic table will look like. So that's the sort of thing that we need to be able to generate in our code. We need to make sure we add the correct tags to the correct place to make sure that our table gets generated in the correct way. So let's head back to the VB editor again, and we'll start modifying the function to include those tags. Let's start by adding in the main table tag. We know that that has to enclose the entire table of data, so we can actually start that before we begin looping over the cells. We can simply say str equals, and then have the open table tag. Now we know that we need to close the table tag after we built the entire table of data, so we can simply add that line to the line after the loop. So we can say str equals str and the close table tag. Nice and simple. The next thing we can do is build in the tags for each row, and we can do that just inside the for each r in film column loop. So I can say str equals str and the open tr tag. And then after we finish looping over that range, we don't need to worry about whether we're on the last row or not to add in the closed table row tag. So unlike with our previous example where we were testing whether we were on the last row or not, to choose whether or not to add in the new line character, every table tag that we open like this has to be closed explicitly. So we'll say str equals str and close tr. So there's the code for the table row tags. We can do a very similar thing now for each table cell. Again, we don't need to check whether we're on the last column or not, so we can remove that if statements all together and simply say for each cell that we encounter, we're going to make the string variable equal to itself and the open TD tag, and then the value of the cell, and then a close TD tag, like so. So actually the code for doing this for an HTML table is actually a lot more simple than with a basic plain text table. We haven't got to check whether we're in the last column of the row or the last row of the table. We always open and close every tag that we open consistently. One thing that we do have to change that I almost forgot to do earlier on is I've changed the name of the function here, getMovieDataHTML. I haven't changed the name of the function down here. I'm not returning the string to the correct function name anymore, so I need to make sure that this matches the name of the function that I've declared up here. Alright, so having done all of that, let's give this subroutine one final test. What we should end up with is a much more neatly arranged version of our table. So an HTML table has very, very consistent spacing between its different columns, and that's how you can generate HTML emails in VB code. One of the useful features of writing HTML emails is that it gives you the opportunity to format the body text, which is something you can't really do with a plain text email. Now there are several different approaches to formatting using HTML. I'm going to start by showing you a quick, simple example of something called an inline style. So just to give you a quick idea of how inline styles work, I'm going to go back to my basic text document, and the idea behind an inline style is that you write an attribute or add an attribute to the tag that you want to format. So if I want to format my entire table, what I can do is apply the style attribute to that tag. So table space style equals, and then inside a set of double quotes, I can list out all the properties of that attribute that I want to change. So for instance, if I wanted to change the color of my font, I could simply say color, colon, red. And yes, colour is spelled the American way again, just as in VBA. So if I wanted to add another property to that attribute, I can type in a semicolon, and then I could say, for instance, font dash size, colon 20px for pixels. As you can see, you kind of need to know your HTML reasonably well in order to make this work. I'm no expert in HTML by any means, but I know just enough, I think, to do some basic things. One more thing I'll do, another semicolon, and I'll say font dash family, colon Arial. So having done all of that now, that should modify everything in the entire table. So if I close this down and choose to save it, and then I'm going to go back to open the file up, changing it to an HTML document first. So I can say HTML, choose yes to make sure that happens, and then double click to open it up in a web browser. So you can see that it's modified all the font properties. It's Arial, font size 20 pixels, and it's different to 20 points by the way, and it's clearly red as well. If I want to make any further changes, I could also if I open this, if I right click on the file and choose to open with Notepad, I can edit it directly without having to change the extension name each time. I could even change individual rows if I preferred. So what I could do here, rather than apply the colour red to the entire table, what I could do is modify the style property of individual rows. So I could say style equals, and then in a set of double quotes I can say colour colon red for the first row, and then for the second one, if I just copy that part out, for the second row I could say colour blue. So having done that, again I can close it and save it, and then open it up in the web browser again. You'll see this time I've got differently coloured rows because of where I put the style attribute. So that's the basic principle. What we need to do now is work out how to incorporate that into our HTML code in VBA. Let's start by applying some basic formatting to the greeting text in the HTML body. So at the moment the Dear Someone line actually isn't enclosing any tags whatsoever. So that just has some basic generic formatting applied. What I'd like to do is control that in a bit more detail. So I'm going to enclose the Dear Someone text inside the P tag. So P is short for paragraph. So if I say P, and then after Dear Someone I can say close P. So that puts that in a proper HTML tag. Now within there I'd like to apply the style attribute, and because this is going to make the rest of the code run off the line, I'm going to use the line or the continuation characters. So I'm going to say ampersand space underscore, then that allows me to carry on typing that line of text on multiple lines. So in this paragraph tag that I've opened, I'm going to put in the style attribute, so p style equals. Now if you remember from the basic plain text document that I was showing you just there, after you have the the style attribute, you need to enclose the rest of the properties inside a set of double quotes. And that's going to cause us a small problem in VBA, because if I try to put a double quote inside a wider set of double quotes here, so I'm trying to concatenate this in one single set of double quotes, this won't work. This will give me a syntax error when I move away from that line. So the trick to doing this is, if you want to include a single double quote in your string of text, then you actually put in 2 double quotes in a row, and that is perfectly fine. The other approach you might have seen as well is if you want to concatenate a double quote character into another string, then what you can do is this. So you can say ampersand, double quotes, double quotes, double quotes, double quotes, ampersand, and that code there will concatenate one single double quote character into the wider string. That's a little bit fiddly, isn't it? So I'm going to revert back to just having 2 double quotes in a row, and that represents a single double quote inside that longer string of text. Right, so having got over that, what we can do now is say things like colour. So let's say colour colon blue, and then a semicolon, and I can say font dash family colon, I'm going to call it Calibri. And then finally, I'm going to change the font size. No, I think I'll leave the font size exactly as it is. So again, now I need to close a set of double quotes inside the for the style attribute. So again, I'm going to put in 2 double quotes in a row, and that will generate the correct formatting for my greeting in the email. So I'm going to give this one quick run through just to see what we end up with, and hopefully we'll find that Dear Someone has changed to blue, and it's in font Calibri now as well. Okay, so that's the basics of using inline styles, and we could go a bit further now and apply lots of inline styles to our table in the getMovieData HTML function as well. Now, although we could use inline styles for absolutely every bit of formatting in the HTML document, it does get a bit tedious doing that, particularly if you find yourself repeating the same style for multiple tags. So a more sensible approach is to use something called an internal style sheet, and that's essentially where you declare all the styles at the top of your HTML document, and then all the tags will just use the styles that you've declared. So just to show you how that works in terms of basic principles, I'm going to go back to a basic version of my HTML table, and I'm going to add a section to the top of this document. I'm going to add the head section. So I open up the head tag and then close the head tag afterwards, and then I can add all sorts of declarations into that section. For consistency's sake, we should also have a body tag which encloses all the body content of the HTML document. So I've got an open body tag and a closed body tag at the end. Okay, so in the head tag itself, what I can do is open up the style tag, and then inside there I can declare all of the individual styles that I would like to use. And it works like this. So let's say I want to format all the paragraphs in the entire document. I type in the letter P to represent the P tag, and then inside a set of curly brackets I list out all the properties that I want the style attribute of a paragraph to have. So I could say, for instance, colour colon blue, semicolon font dash family colon Calibri, and so on and so on. What I could also do is apply a table style, so I can say table and then open and close curly brackets, and then in there I could say things like, again, colour colon blue, semicolon font dash family Calibri, and I can also put maybe a border around the table as well, so another semicolon, and I can say border colon 1px, so it'll be 1 pixel wide, and I want it to be a solid border, and I'd like the border colour to be blue as well. Okay, so there's some basic styles declared. What I can do now is save that document, close it down, and then I can open it back up again in Internet Explorer, and I should see that now that all the text in the table is blue, and it's got a single pixel border that's also blue around the outside. So if that's how I can declare styles for the entire document, I simply need to work out how to attach or insert that into the main string that I'm returning to my getMovieData HTML function. In fact, rather than modify the existing function which already does a particularly useful job, we'll create a new function altogether that will generate the HTML head section. So down below I'm going to say function getHead HTML, and that's going to return a string. Enter it a couple of times. I'll declare a string variable in there that I'll use to build up the HTML text, so dim str as string, And then we can simply start concatenating this to build up the head section. Let me give myself a few blank lines to make this a bit easier to read. And we can start by saying str equals, then in a set of double quotes, I can say head and then style. So that will open up the head and the style tags, of course. I'm going to join on a VB new line character here just to make this easier to read when I test it later on. You don't need new lines in your HTML code. This is again just purely to make it easier for us to read. Then I'm going to say str equals str and let's start with the paragraph or the p tag. So I'm going to say p followed by a space, open and close some curly brackets, and then inside the curly brackets I'm going to say things like color, :blue, semicolon, font dash family, colon Calibri, semicolon, should we say font dash size, colon 20px as well. Then at the end of that line I'm also going to concatenate another new line character, and then we can carry on and let's declare the style for the table tag this time. So I'm going to say str equals str and open some double quotes, table, open and close some curly brackets, close the double quotes, and then actually I'm going to copy and paste all the properties for the paragraph that I've already declared, just for the sake of convenience and to stop boring you guys watching me type out lots of different properties. I'll also add in the border property for the table as well. So I'm going to say border colon 1px solid blue. I'll add one more new line character to the end of that, then I think that's probably enough just to be able to demonstrate the principle of this. What I'm also going to do then is say str equals str and I'm going to close the style tag and I'm going to close the head tag, and then I'm also going to open up the body tag. So we're going to assume that this function always returns the complete head section, and we might as well open the body tag at the same time. So that will generate the complete string. All I've got to do now is say get head HTML equals str. Now to make sure that it's generated the correct sensible looking HTML code, I want to quickly test the function using the immediate window. So I'm going to head to the view menu and choose immediate window. I'm going to say question mark get head HTML. When I hit enter, this should print out what looks very much like the head section of a basic HTML document, and that looks reasonably good. So going with that, what we can do now is incorporate this function into our main subroutine. To start with, let's get rid of the inline style from that paragraph tag. We won't need that anymore because that's what our style section in the head of the email will do. Then let's concatenate the result of our getHeadHTML function. So let's say getHeadHTML and our opening paragraph, dear someone. Then we'll get the result of the movieData function, or getMovieData function, which will do its same job as last time. Then we'll join on the signature, essentially, which is what the HTML body property will give us. And finally, I suppose technically we should close the body tag as well. As we opened the body tag in our getHeadHTML function, we should also make sure that we close the body tag at the end. Now, if you know a little bit about HTML, you're probably wincing at this point in thoughts of the horrible mangled mess of HTML we'll get here. I'm going to come back and mention that in just a moment. Just for the time being, we're going to run this subroutine just to prove that the head section and the styles in the head that we've added do affect the rest of the email. So again, it doesn't look particularly beautiful because I haven't spent much time choosing specific formats for various things. But with a little bit of knowledge of HTML and understanding that you can add styles to the head section of the email, you could end up with some neatly formatted things. I'm not going to go any further in terms of adding more styles because, first of all, it's not my forte. I'm not very good at formatting in the first place, and I probably don't know quite enough about HTML myself. I'll leave that up to you guys. What I do want to think about just briefly is how we can make sure that the HTML that we're generating in this email is actually sensible HTML. Okay, so this is really just meant as a fairly quick note for the HTML purists amongst you, just to explain what happens when you concatenate all these bits of text together to generate the email. What I'm going to do is I want to print out the result of the HTML body property after I finish generating it. So I'm going to use a debug.print statement, and I'm going to say .html body. So that will print that into the immediate window. The first time I do this, I want to avoid concatenating the original HTML body text, just so we get what we ourselves have generated. This is purely composed of the two functions and that greeting line. What we'll do then is run the subroutine, and you'll see that we get a basic email. It doesn't incorporate the signature because of course we haven't concatenated that to the end, but that's okay. And what I'd like to do now is view the immediate window to see what we've got. So you'll see that it starts with exactly what we typed in ourselves earlier on in the getHeadHTML function. And it also ends at the very end there with the close table tag. So weirdly, although we didn't include the close body tag, this HTML still works to generate the correct email. Technically speaking, we should have a close body tag here. And in fact, technically speaking, there should be all sorts of other tags associated with this email as well. Technically, the whole thing should be wrapped up in an HTML tag to make this work, and we should have a close HTML tag right at the end. So hopefully what you can get from this already is the fact that Outlook is fairly forgiving in terms of generating the correct document, even though the HTML isn't 100% complete. And that goes even more for when we do incorporate what the original body text includes. So I'm just going to clear the immediate window. I'm going to press Ctrl A to select everything, and then Delete to clear it out, then just close it down temporarily. I'm going to bring back in this the original HTML body and the close body tag, and then I'm going to run the subroutine again. And again, recognise that you get a complete email that's displayed properly that we could happily just send, and we get the signature text at the bottom, all looking sensible. But the HTML itself looks absolutely awful. If I view the immediate window itself actually isn't even big enough to display all of the information in the HTML of the email. There is a limit to how much text can be displayed in the immediate window, and we've far exceeded that. So basically everything from the bottom of the window here, this is, hopefully you can see the signature text of our email. Scrolling back up, this is all of the other stuff that's associated with the original HTML body property of that email. So there's all sorts of styles and classes and all sorts of other declarations. In fact, I haven't got enough space to display everything else, but we can't even see the text that we've generated for the email. So this part here and this part here actually isn't even included because the immediate window isn't large enough to display it. What we can hopefully see, if I can pick it out quickly, is the fact that in this section here, can you see we've got a close style tag and a close head tag and another open body tag? Well, technically we've already done that, haven't we, in our function earlier on. This close style and close head tag here definitely is not part of our function text. This is part of the original HTML body of the email. So our email actually consists of at least 2 head tags, at least 2 style tags, at least 2 body tags. But even though all those discrepancies are part of the HTML, Outlook happily displays a sensibly formatted email. Basically what I'm trying to say here is, even though, if you're a purist, this is absolutely horrible, you can relax. You can rely on the fact that Outlook will generate a sensibly formatted email, even if the HTML looks absolutely awful. We could spend absolutely ages generating a new function that takes the original HTML body and finds just the signature text in there to make sure that we only get the correct part of the HTML text that we want. But it's irrelevant. You don't need to do that. Outlook takes care of it for you. A little later in the video, I'm going to show you an alternative way to insert signature text into an email, which will hopefully make you a little bit more relaxed about this if this is bothering you. But for now, we're just going to accept the fact that Outlook's pretty forgiving when it comes to horribly formatted HTML. So I'm going to take the debug.print statement away, and that will give us our nicely formatted HTML email. So we've dealt with basic plain text emails and now HTML emails as well, and hopefully you have a reasonably good idea as to how those work. What we haven't looked at yet are the rich text format emails, and I've been deliberately saving those until towards the end of the video because they're a little bit more difficult to work with than you might expect. So what I'm going to do is make a copy of this subroutine that we've just been using and then create another new module. So I'm going to insert a new module, and I bet you can guess what I'm going to call it, using Outlook Part 4. And then I'm going to paste that subroutine into the module and change a couple of basic things to make this work as a rich text format email. First of all, First of all, I'm going to change its name. So I'm going to send complex email RTF. Then I'm going to change the format or the body format of the email to an OL rich text format. And then we're going to remove this line here altogether. We're not going to change the HTML body at all. What we're going to do first is try to change the RTF body property. And I think I showed you this earlier in the video. If I try to change the RTF body to be equal to, let's put in our standard greeting, dear someone, then this will absolutely fail. If I run it, we'll get the empty email, but it doesn't fill in any of the values, and that's the reason for that is because it's crashed with a runtime error at the point where we try to set the rich text format body property. Now the reason this fails is because the RTF body property doesn't contain a string of text. What it actually contains is an array of bytes. I'm going to come back to that idea in just a moment. What we're going to do first though, rather than try to set that property, we're going to try to just read it simply. So I'm going to add a debug.print statement, debug.print, and I'm going to try to print .rtf body. So I'm going to display the immediate window, first of all, which is empty currently, and then I'm going to run this subroutine and see what we end up with. So there's the email that we generate. I'm going to close that down, and the RTF body of that email looks like a complete list of absolute nonsense. There's absolutely no useful information there whatsoever. So what we need to do in order to see anything useful at all in the first place is to convert that array of bytes into a sensible string. And there's actually a function that will do that for us in VBA. It's called strconv, string convert or string conversion. So if I open a set of parentheses, the first thing you specify is what string you're trying to convert, and then the second parameter says what you're trying to convert it to. So I'm going to try to convert this array of bytes into basic Unicode text. So I'm going to use VB Unicode and close the parentheses, and then if I run the subroutine again, I'll get an email, and I can close that down, and then I can look in the immediate window, and I get, although as well as a list of nonsense, I do actually get some intelligible bits of text now as well. So this is basically what RTF text looks like. It's a set of encoding that dictates how to display the text as well as the text itself. So this is what makes it so difficult to actually set the values of the rich text format property. Of the rich text format body property, but we can make a stab at this. What we're going to try to do, I'm just going to get rid of the immediate window here after I've cleared it out. What we're going to try to do is just add a basic greeting to this simple email. We're going to try to put in the dear someone greeting. So to do that, we need to do effectively the reverse of what we've done here. We need to encode the phrase dear someone as an array of bytes. And we're going to store the result of that conversion in an array, which we're going to declare at the top of the subroutine. So let's say dim str, open and close brackets, as a byte. Now, you don't need to know too much about arrays in general to make this system work, but we do have a video that explains arrays in a huge amount of detail if you're interested. So that's earlier in the series. What we're going to do here, however, is simply convert, storing that array, str, open and close brackets, equals strconv, open parentheses, and what we're trying to convert is the phrase dear someone, and we're trying to convert that from Unicode this time. It's going to use VB from Unicode. So once we've done that, we can then set the RTF body property to be equal to the array of bytes that is stored in that array. So let's give this one a quick test. If we run it, we should find that we can successfully set the RTF body property to the phrase dear someone. Of course, we've lost the signature text. There's not much we can really do about that at this point, but at least we can successfully set some text in the email. But that's a huge amount of effort to do, and it's very, very awkward to do things much more complex than this with RTF format emails. What would be a much, much better solution would be to, rather than write out explicitly all of the text into the RTF body, is to use the editor that is used to generate these emails. So this is kind of the point we've been leading up to in the whole video. Rather than explicitly writing out text into the email using the body or HTML body or RTF body property, we can actually get access to the Microsoft Word editor, which makes life an awful lot easier. Now, the approach to using Microsoft Word to edit the content of your email is a little bit different to what we've done so far, but the basic structure is the same. So what I'm going to do is copy this subroutine that we've written already, and paste it in down below. And of course I'm going to need to change the name of the subroutine, so I'm going to call it send complex email. In fact, I'm going to just say send email using Word editor, actually, technically. So we can remove any reference to an array, so we can get rid of that altogether. We don't need to do any sort of conversions from strings to arrays and vice versa, so we can get rid of all that as well. Tidy up a little bit. What we do need to do is declare a couple of extra variables, and the first variable we're going to declare is something called OLInsp, which is short for the word inspector, and the type of object we're going to store in there is a reference to an Outlook.inspector. An inspector is essentially the tool that lets you view and edit an email. It's like the window that you use to edit the email itself. The inspector object then gives us access to something called the word editor, and the word editor of an inspector actually returns a reference to a Microsoft Word document. So what I would like to do next is say dim wd.doc as a Word document, but as you can see I don't have the ability to do that at this point. The IntelliSense list shows me no reference to Microsoft Word or to a document object. So as you've probably guessed already, what we need to do is head to the Tools menu and choose References. And if you followed the video on Microsoft Word prior to this one in the series, you'll be very familiar with how this one works. We're going to look for the Microsoft Word object library. See if I can avoid scrolling past it as I usually do. Nope, happened again. Go back up a little bit. There we go, Microsoft Word 15 in my case, but whichever version number you have is the one to go for, of course. Click OK, and then I can say dim Word doc as Word.document. Okay, the next thing we need to do is get references to both of those objects in our with statement. I'm going to do this after we've set the basic properties of the email. So we're going to say, first of all, set OLInsp equal to, and then there's a property of the mail item object that gets the inspector. So I can say dot get inspector. Nice and simple. Now that I've got that stored in a variable, I can set a reference to the Word document by saying set wd.doc equals OLInsp dot, and there's a property of the inspector object which is called Word editor, and that returns a reference to the Word document. Now the beautiful thing about this is that once we've got a reference to the Word document, we have access to all the methods and properties you'd expect to have from Microsoft Word. So this is where things get really interesting and hopefully a lot more useful than building an email bit by bit by bit using the body property. So, just to give you an idea of some of the basic things we can do here and hopefully how easy it is to do, let's start by adding the basic greeting to our email, the generic Dear Someone greeting. What we need to do is reference our Word document, so we say wd.doc dot. Then we need to reference the range method of that document. Range allows you to specify a specific range of characters, essentially, of the document. There's two optional parameters, start and end. We don't actually want to reference any specific character here, we're just referencing the entire range of the complete document, because what we're going to do is insert a line before the current range. So we're going to say .range insert before. Now the insert before method has a single compulsory parameter, text as string, so what I'm going to do here is say Dear Someone, and then I'm going to concatenate a couple of VB new line characters as well, so and VB new line and VB new line. Okay. So once I've done all of that, what I can do is run the subroutine, and I'll end up with my email with the phrase Dear Someone, a couple of line breaks, and then the signature as it stands. It's worthwhile mentioning that this works as well as rich text. It will also work happily with HTML as well, and I suppose probably with plain text, but certainly with HTML, like so. And let me just give this one a quick try with plain text. I haven't actually tested this with plain text. Let's have a quick look. So yeah, it does, of course. The disadvantage is using plain text, of course, and the reason we want to use Word as the editor in the first place is so that we get access to all the lovely formatting features. So let's revert to a rich text format there. Okay, so there's the basic line of text inserted, the greeting. What I'd like to do now is put in our table of data from Excel. Now previously we've had to do this cell by cell, essentially, and read these values into the email using the body property. The beauty of using Word is that we can do this as a simple copy and paste. So that's exactly what we're going to do. So back to the VB editor, and to start with, let's say sheet1.activate, and then we can say arrange a1.current region.copy, So that copies it all to the clipboard. Now we do have to be a little bit careful with how we paste this into the document. So let's just have a quick look at how you can do this. To start with, I'll need to reference the word document, of course, so I'll say wddoc dot, then I need to reference the range method, and again I'm going to avoid using the optional parameters at this point. I'm just going to say range dot paste. Now if you've seen the previous video we've created on Microsoft Word, you'll be familiar with all the various methods of pasting things into the Word document. There's even a dedicated one for an Excel table. But for this example I'm just going to go with a basic paste method. So having done that, I'm going to run the subroutine and see what we end up with. There we go, we end up with essentially an email that consists of just that table. You might have seen before the table got pasted in, you might have just quickly spotted the Dear Someone greeting and the signature text. But because we've referenced the entire range of the document, the table gets pasted in over the entire range. So this is where these optional parameters come into play. If I open up some round brackets after the word range, I'm going to specify a start position for pasting in this table. And just for the sake of demonstration, just as a very quick and simple example, what I'm going to do is I'm going to paste this starting at position number 5 in the range of the document. So, position number 5 essentially represents this character here. The word dear contains 4 characters, and then the 5th character is the space. So it doesn't make sense to do this in the real world, obviously, but this is just for the sake of demonstration. It's a nice, easy way to show you how this works. As we know that this is the starting point of our entire document, character number 5 of the document will be that position there. So if I run the subroutine at this point, what we will see is hopefully the word dear, and then the entire table that gets pasted in. And we've lost the signature again, because essentially what we've done here is we've said from character position number 5, replace that with whatever's being pasted from the clipboard. So ideally what we would want to do, if we want to insert the table in at a specific position, we also need to specify the end of the range we're pasting into. So if I actually just use the same number there, the number 5, essentially our table gets pasted in at that point there. So if I run this one more time, we will see the word dear, then our table, and then you can just make out there the word someone, and then the signature at the bottom. Okay, so that's still not perfect, obviously, is it? What we really want to do is make sure that our table gets pasted in after whatever greeting we've added. So let's do that bit next. Ideally, we'd like this system to work so that regardless of the length of the greeting that's added to the email, the table always gets pasted in immediately after it. So the easiest way to do that is to actually store the greeting text in a variable. So what we're going to do is say dim str greeting as a string, and then we're going to say str greeting equals, and then I'm just going to copy this string of text. In fact, I'm only going to use one new line character here. Let's just copy a single line character and paste that in there. Then, whenever we're inserting that greeting, we don't need to reference or explicitly write that out again. We can just reference the str greeting variable. Now that we've done that, what we can do is modify the way the range method works. So rather than inserting a specific position, what we can do instead is calculate the length of the text stored in that string greeting variable. To do that, we can use the len function. So I'm going to say len open brackets str greeting, and then close some brackets, and then again do the same thing here, len str greeting. And I guess we could have stored the result of that in another variable as well, as we're referencing it more than once, but this will just demonstrate the principle fairly neatly. So, having done all that, I'm just going to run the subroutine one more time, and we ought to get our greeting, dear someone, with a new line character, then the table, and then our signature right at the bottom. So, I hope you're in agreement with me. I find this by far and away the most convenient way to generate emails, referencing the word editor. The beauty of it is, because you're just copying and pasting stuff from Excel, it retains all the standard formatting from Excel. You haven't got to worry about where to put in new line characters or tab characters or any of that sort of stuff. So those are several different methods for generating emails. I think that's almost enough for one video. There's possibly just one more thing I'm going to mention. Now we've mentioned the idea of using signatures in the email several times so far. We've made sure that we always include the default signature at the bottom. What we haven't dealt with yet is how you choose between different signatures. Outlook supports having multiple signatures available for any email, and there's always a default one, which in my case is my work signature, but I've also got a personal signature as well, which actually I've just created for the sake of demonstration. It's very simple, it just says cheers Andy, and then I can quickly change between those two using the signature tool in the email. What would be lovely is if I could use a simple method or a property to switch between the signatures that I'm using when the email's been generated. But unfortunately I can't do that. There is no simple property or method of a mail item that lets me do that. What I have to do instead is open up the file that contains the signature text and read that into the email object. So you'll need to know a little bit about how the signature files get saved. If I just quickly take you to a Windows Explorer window, I've already browsed to the correct path for my signatures. This will be something similar on your own computers, of course, depending on which version of Windows you're using and what your username is. But you can see that I've got, for each different signature, I've got 3 different files. You can probably work out why there are 3 different files. I've got a TXT file for plain text emails, an RTF file for rich text format, and an HTML file for HTML emails. So what we would have to do to make this system work is make sure that as well as being able to choose the correct signature, personal or work in this case, we'd also have to choose the correct file type for the version or the format of the email we're creating. So let's start by going back to the VBA editor, and I'm going to go back to a very, very basic version of our email code. I'm going to go back to the original using Outlook module, and this is where we ended up with our first basic emails. We'll modify this one to create the email and choose the correct signature. I'm going to start by tidying up a little bit in this subroutine. I'm going to get rid of the send method that we added in for demonstration earlier, and I'm also going to get rid of the bit that adds on or concatenates the current HTML body. So that's how we added the signature earlier. We're going to do this in a completely different way this time. The next thing is I need to be able to talk to files and folders, because we need to actually open up one of the signature files to read its contents. And the best way to do that is to rely on an object library called the Microsoft Scripting Runtime. So we head to the Tools menu and choose References, and then scroll through the list to find Microsoft Scripting Runtime. Now you may have seen the video that we created earlier in the series on how to use this, so we're not going to go into too much detail in this particular video, just to show you that you can reference it by ticking the box and clicking OK, and then we can use it to declare a couple of extra variables. I'm going to call the first one FSO as scripting.filesystemObject, which is essentially like an application that allows you to modify and manipulate files and folders. And then we're going to also have something called TS as a scripting.textstream. We'll also have a basic string variable for storing the path of the signature file we want to use. I'm going to call this one sigpath as string. And then we want to store the path of the signature file in that variable. So I'm going to say sigpath equals. Now I could, I suppose, just use the specific file and folder path that I showed you earlier on, so that would be specific to me as a user, but I think it makes more sense to use the environ function to generate part of this path and then tag on the extra part ourselves. So what we will do is just quickly show you the version of the environ function we're going to use in the immediate window. We can use environ, as you've seen several times in previous videos. This time I'm going to use the app data folder. So if I search for that, you can see that it gives you everything up to the folder roaming in this particular version of Windows. So we need to tag on the remaining part of that, which will be Microsoft Signatures. So what we will do is sigpath equals environ app data ampersand and then backslash Microsoft, Microsoft, spell that properly, backslash signatures, backslash, and then to begin with, what we're going to do is let's use the personal signature. So I'm going to say personal dot, and the important thing here is that we use the correct file type for the type of email that we're creating. So in this email we're using HTML formatting, so I'm going to use the HTM signature or extension. Okay, so that will store all the correct values. What we now need to do is actually open up that file and read its contents somewhere. So to do that, we need to create a new instance of a file system object. So we can do that in exactly the same way that we create a new instance of Outlook. Let's say set FSO equals new scripting.filesystemObject. We can then set a reference to the text file that we're opening in the text stream, or the ts variable, by saying set ts equals fso.open text file. If I open a set of brackets there, a set of parentheses, it shows me that there are several parameters I can fill in. The main one, the compulsory one, is file name. So that's going to be the file name and folder path stored in sig path. I can also choose what input-output mode I use. By default it's open for reading, which is actually the one that I want, so that's actually all I'm going to do. I'm going to pass in just the file name, and that will open the file into memory. Now what I need to do is read the content of that into somewhere else. I haven't actually created the variable, created the email at this point yet, so what I'm going to do here is declare another variable, which is going to be called sig text as string. And what I'm going to do is I'm going to read the entire content of that text file into the sig text variable. So I'm going to say sig text equals ts dot read all. So that reads the entire content and stores it in that variable. What I can now do is close down the text file by saying ts.close, and then I can say set fso equals nothing, just to tidy up a little bit, so I can release the variable as soon as I've finished using it. And now all I need to do is down towards the bottom of this subroutine now, where we're generating the HTML body text, I simply need to say ampersand sig text. So that will put in the contents of what I read out from the file earlier on. So just to give this one a quick test, if I run it, just to see if it will work with an HTML document, we should end up with the personal signature. I could do with another couple of line breaks there, couldn't I? But if I close that one down, don't bother saving the changes, let's add in another BR, and let's change it to the work version. So change it with the word personal to the word work. If I run it this time, we ought to end up with the work signature instead. So that's the basic principle, although it's a bit rough and ready at this point, having added all the code to the same subroutine. What might make a better solution here is actually creating a separate function that will always return the correct signature text. Let's start by declaring a new function at the bottom of the module. So I'm going to call this one function getSigText, and that's going to return a string as in the past. So we've done that. Now we can take essentially all of the extra code that we added to this basic subroutine. We can essentially just cut the whole section of code from where we declare the variable for a new scripting file system object all the way down to where we set that variable to be nothing. We can cut that from the subroutine and simply paste it in to the new function. Okay. So the next step is then to provide a couple of parameters for the function that lets the user choose, first of all, what type of signature they want, whether it's HTML or rich text, etc., and then also which actual signature they want, whether it's work or personal or perhaps something else. The first parameter that we'll add will let the user choose what type of email they're creating or what type of signature they want. So we've got a specific list of those types already, haven't we? We've used them several times in the previous subroutines where we're setting the body format. We have a specific list of options available. What I'd like to do for my function is provide exactly the same list of options as the body format property. So that involves finding out which collection or which enumeration that particular constant belongs to. You can find that out using the object browser. If I view object browser from the menu, and then I'm going to limit my list to just those options that are part of the Outlook library. And then in the right hand side I'm going to scroll down the list to find that option I was just looking at, OL format HTML. That's a good starting point. So scroll down the huge long list of various options. These are all the constants that are part of Outlook, and there's the one that I want, OL format HTML. If I select it and look down at the bottom part of this window, it tells me that this is a constant, we've mentioned that before, but it's also a member of something called an enumeration, and this is outlook.olBodyFormat. If I click olBodyFormat, that will take me to this specific list, and again, this is just mentioning the idea that this is an enumeration. An enumeration is just a list of constants. We've created a video on constants and enumerations previously in the series, so again, not going into too much detail here. All we want to do is make sure that the parameter that we create for our function allows the user to choose from one of these olBodyFormat constants. So let's get back to the VB editor. Let's the code. Let's close down the object browser. And for the first parameter, we're going to call this one, what should we call it? Let's call it sig type as OL body format. Now what this means is when I call on my function in the main subroutine, so we're going to call on this function here where we're adding the signature text, we're going to say and get sig text, and then we'll open up a set of round brackets, and that will give us the list of options available from that enumeration, which is quite neat. What I have to do now is take the value that's passed in through this sig type parameter and convert it into the correct extension text, either .htm, .txt or .rtf. So to do that, I'm going to declare another variable here. I'm going to call this one sig ext, short for extension, as a string. And then I'm going to we could use a case statement or an if statement. Let's use a case statement. I'm going to say select case sig type. And then I can say end select down at the bottom. And inside there I can say case. And I'm going to use the enumerated values again. So I'm going to go for OL format, format HTML. And when that's true, I'm going to say that the sig ext equals .htm. And then the other two possibilities, again, will work in a similar way. So I can say case OL format RTF, or rich text, sorry, and then the sig ext will be equal to .rtf. And then finally we've got case OL format plain. And for that I can say sig ext equals .txt. Okay, so that will generate the correct extension name. What I can do then is replace that part of my signature path with a concatenation. So I can say ampersand sig ext to put on the correct extension. The next thing that we can do is provide another parameter in the function that lets us specify which signature file we want to use. So we'll just use a basic string parameter to do this. Let's call it signame as string. And then what we would do is in the line which calculates the signature path, we can remove the word work there, and then simply concatenate in whatever the value of the signame parameter is. I've got my ampersand, sorry, I thought I typed that in. There we go. So ampersand signame, ampersand sigext. So that means that when I call this function in the other subroutine, I'm going to have to specify which particular signature I want to use. So I could put in work. What I prefer to do, however, because I'm using work primarily for my emails, what I'd like to do is give this parameter a default value and make it optional. So to do that, I can type in the word optional in front of the parameter name, and then after the words as string, I can say equals work. So that means now that when I call this function, I don't always need to specify what the signature name will be. If I type in a comma, you can see that it is set in a set of square brackets. The parameter name is optional and it has a default value of work. So I'd only ever need to provide a value if I wanted to use the personal signature. So one more thing that I need to change about this function before it will actually work is to make sure it returns a value, because currently it doesn't. Right at the end, I'm going to say get sig text equals, so we've got get sig text equals the result of this signature text variable. So that's the variable into which we read the contents of the text stream. So I'm just going to say sig text, and that will return everything to the function. So let's give this one a quick test at this point. If we go to the subroutine and run that one, we should see that we get an HTML email with the work signature. Let's close that down, don't bother saving the changes, and let's try adding in the personal signature this time. So I'm going to use personal. Of course, this relies on us knowing the names of all of our signature files, which might be a point of issue if we don't know the names or if we type in the name incorrectly. But let's run the subroutine just assuming that we've got this correct. And there we go, we've got the personal signature in there as well. So that establishes that it works for an HTML email. What if we try to change the type to, say, plain text? I'm going to make a copy of this entire subroutine and paste it in below the function. And then we're going to make a few modifications to make it work as a plain text email. So let's put in as an extra keyword in the subroutine name as plain. So we're going to modify the format of the email first of all. So it's not going to be an HTML format, it's going to be a plain format. And that means, of course, that we'll need to modify first of all where we're concatenating the break tags, we need to replace that with a VBA VB new line or VBCRLF. And also, where we're getting the signature text, we don't want to get the HTML file, we want to get the plain file. So we do this in two ways. We could say explicitly OL format plain, or it actually makes sense really to actually call on the current body format of the email. So ignore the IntelliSense list. What we can do there is say dot body format. So it will read whatever we've set there. It means we only need to change it in one place. I'm going to revert to using the work signature as well, so I'm going to remove personal from the call to the function, and then let's also modify where we're changing the HTML body just to the generic body property. Right, so having made all those changes, let's try and run this one and see what happens. Oh dear, that's not very successful. So we get the a slightly weird version of the signature text from the text file. That's because there's one extra property or one extra parameter of the open text file method that we haven't set yet. So let's close down this email and let's go and resolve that problem with the open text file method. The parameter that we're interested in is actually the fourth one in the list for the OpenTextFile method. It's one called format as tristate, and unsurprisingly this controls the format that the file is opened in. Now you can see it has a default value of tristate false, and what this means according to Microsoft's literature is that this file opens up as in an ASCII format. We could use tristate true to change it to a Unicode format, and that would be perfect for plain text, but that would actually mess up the HTML version of the signature. So what we're going to do instead, we're going to choose tristate mixed, and that will allow the file to open up in the correct format for whichever type of file we're opening. So having done that, if I run the send basic email plain and check that that works, we ought to get a sensible format for the signature file, and we do. And then if I close that one down without saving the changes and go back to the HTML version and make sure that that still works, we should get a sensibly formatted signature for that as well. Let's just make sure that it works for both signature files. So rather than personal, we'll use the work signature for HTML. Just make sure that that still works. And eventually, there we go, we get the correct results. So there's a reasonably useful function for generating the correct signature text for your emails, depending on which type of email format you're using and which signature file you want to use. Now previously I mentioned that this function is reliant on us always passing in a correct name for the signature file that we want to use. So if I tried to call the function and I passed in the name of a signature file which didn't exist, so I don't know, let's misspell the word work for instance, and try to open up that signature file. If I run this subroutine now, although to begin with it will appear as though the subroutine's worked, you get the signature file in place. However, closer inspection reveals that you haven't filled in the to field or the subject or written out the body text, etc. So if I close the email down without saving the changes, we'll see that the subroutine has failed with a runtime error, and if I click debug, it's failed on the line which opens up the text file because that path doesn't actually exist. So what we could do is actually test to see if the signature path that we create exists using a method of the file system object. To do that, after we've generated the new instance of the file system object, we can use an if statement to check if that signature path actually points to a file or not. And if it doesn't, then we can set the signature path to be equal to a known file path. So we're going to say if not fso.file exists, and we're going to pass in the signature path, then don't forget end if. So that essentially says if the signature path doesn't point to an existing file, then we're going to reset this to be pointing to a known signature file. So I'm just going to copy and paste that line, and then take out the bit that concatenates the signature name, which we know at that point doesn't exist, and instead replace it with a known file name. So that's going to be the work file. So that means that whenever we try to call this one and we search for or try to pass in nonsense or at least the name of a file which doesn't exist, then it will just revert to using the standard work signature. So there we go. That's a slightly more robust version of that function. If you've enjoyed this training video, you can find many more online training resources at www.wiseowl.co.uk.